Hi, I'm Ms. Hearn. Let's get started. In this video, which is the second example of how to use this limit fact to find other limits, we're going to find the limit as theta goes to 0 of 1 minus cosine theta over sine of 25 theta. So we're going to need to know and kind of use as a tool that the limit as theta goes to 0 of sine theta over theta is 1. But we're also going to need to use this identity. It's one of the Pythagorean identities because it comes from the Pythagorean theorem. It says that sine squared plus cosine squared equals 1. In our problem, we're going to want to rearrange this and notice that sine squared of theta must be equal to 1 minus cosine squared of theta, if that's the case. So coming back to our limit, I know it's like a hint, right, that I'm going to have to use sine of theta over theta somehow. But right now I don't have that. And so whenever you have a situation like this, you just kind of keep that in mind and you try whatever you think might work, really. So start trying some identities or rearranging algebraically. What I decided to try was to go ahead and change this numerator to be a sign, because I don't have a sign in a numerator. Eventually I'm going to need that, right? So I thought, how can I get 1 minus cosine theta to be something to do with sines? So I thought, well, 1 minus cosine squared theta has to do with sines, and I can get 1 minus cosine squared theta by multiplying 1 minus cosine theta times 1 plus cosine theta its conjugate. And of course, whatever we do in the numerator, we must do in the denominator as well. So I said, let's see what happens if I multiply this out. So we get the limit as theta goes to 0 of, we're going to have 1 squared, which is 1, minus cosine squared theta, over, and then we have sine of 25 theta times 1 plus cosine of theta. I'm not going to multiply that out yet. Let's see what happens. Okay, so I'm going to replace 1 minus cosine squared theta with sine squared theta. So we get the limit as theta goes to 0 of sine squared theta over sine of 25 theta times 1 plus cosine of theta. Okay, now let's see where we are. Oh, first of all, and I really should have mentioned this at the beginning, but we would like to just plug in 0 to evaluate this limit. The reason we couldn't do that in the beginning is because we would have gotten 0 in the denominator. Sine of 0 is 0. And in the numerator, cosine of 0 is 1, so we would have had 1 minus 1 in the numerator, which is also 0. So that would have meant that we had 0 over 0, which is in an indeterminate form and gives us no information about the limit. So that's why I had to go ahead and that and the hint that I knew that I was going to use sine of theta over theta was why I knew I needed to start manipulating things. Let's just check where we are with that just to get an idea. We know sine of 25 theta, that's still going to be 0. But 1 plus cosine of theta, that's 1 plus 1 when you plug in 0. So that's going to be a 2. So this factor is actually not causing us any trouble. This one is still 0 if we plug in 0 for theta. So at this point, I started thinking, well, if the problem is that I need this sine of theta the sine of 25 theta not to be going to 0, what if I forced this to take the form that we know we're going to use? Remember, we're using the limit as theta goes to 0 of sine of theta over theta equals 1. Well, this works if you have sine of any expression over itself. Like, for example, the limit as theta goes to 0 of sine of 25 theta over 25 theta would also go to 1. So I just need some denominator 25 theta under this sine of 25 theta to get it to go to 1 instead of 0. So I'm going to multiply the numerator and denominator of this big fraction by 1 over 25 theta and see what happens here. So this gives me the limit as theta goes to 0 of, now up here, I am going to think of this as 1 over 25 theta times sine of theta times sine of theta. I don't want to sine squared theta because I think if I separate this out and kind of group it this way, then I'm going to get something of a form that I can work with. And then in the denominator, I'm going to have sine of 25 theta over 25 theta times 1 plus cosine of theta. Okay, so this is going to be the same as the limit. I'm trying to get as many things in the form of sine theta over theta as I can. The limit as theta goes to 0 of, I'm going to leave this 1/25 out front and have sine of theta over theta. See how I separated the 1 over theta from the 1/25? And then I have this other sine theta over here. And then in the denominator, I still have sine of 25 theta over 25 theta times 1 plus cosine of theta. Okay, so now let's think about what happens to each of these factors as theta approaches 0. So 1/25 is going to stay 1/25. Sine of theta over theta is going to 1. Sine of theta, as theta approaches 0, approaches 0. Sine of 25 theta over 25 theta is going to go to 1. And then 1 plus cosine of theta is going to go to 1 plus 1, or 2. So we no longer have an indeterminate form. We have 0 over 2, which is 0. And that's the limit that we're looking for. We just found that the limit as theta goes to 0 of 1 minus cosine theta over sine 25 theta is equal to 0. I hope you found this video helpful. If you did, please remember to like it. That helps other students to find the video.